Example number 7. Find the derivative of the given function y equals 575 divided by 36 plus 5e to the negative 4x. Have a couple of options here. You could move this denominator to the numerator and give it a -1 exponent. So while we have some options here, I think the quotient rule will be the easiest. And don't forget, we're going to need our chain rule because we have an exponent that we can take the derivative of. So our numerator is 575. Our numerator prime is 0 since that's a constant. Our denominator is 36 plus 5e to the negative 4x. And the derivative of our denominator is the derivative of 36 is 0, so it's 5e negative 4x times negative 4. So I'll go ahead and write that negative 20e to the negative 4x. So now I'll use the quotient rule. The quotient rule says denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So our dy dx is our denominator, so it's this whole thing, 36 plus 5e to the negative 4x. You need to put that in parentheses. The derivative of our numerator is a 0, so that's going to actually become a 0 because anything times 0 is 0. Then minus our numerator, 575, times the derivative of our denominator, negative 20e to the negative 4x. And all of that is over the original denominator, 36 plus 5e to the negative 4x, and all of that is squared. So since this is going to be a 0, that's going to cancel to 0. Then I'm going to have a negative times a negative, so that's going to be a positive. 575 times 20, so that's 11,500 times e to the negative 4x. All of that is over 36 plus 5e to the negative 4x quantity squared. Now, because of this plus down here, we're not going to be able to reduce that in any way because these two terms that are added have to stay together. So our final answer is 11,500 e to the negative 4x divided by 36 plus 5e to the negative 4x all squared. Example number 8. Find the derivative of the following function. Y equals base 5 to the 10x plus 1. So for this function, we need the rule for exponential functions where the base is not e. So dy dx is 5 to the 10x plus 1 times 10, because that's the derivative of the exponent, times the natural log of the base. So that's the formula. And we can rewrite this a number of ways. We could put the 10 in the front, times 5 to the 10x plus 1, times the natural log of 5. You could put the 10, the natural log of 5, times the 5 to the 10x plus 1. Any of these will be acceptable as long as it's clear that it's multiplication of each one of these factors. So our final answer is 10 natural log of 5 times 5 to the 10x plus 1. Example number 9. Find the derivative of the following function. Y equals 9 to the 5x plus 1. So here we have a non-e base to a power that we can take the derivative of. So we'll need a to the x rule and we'll need the chain rule. So dy dx for this will be the original in its entirety, 9 to the 5x plus 1, times the derivative of the exponent, which is 5, and then the natural log of the base, which is 9. You may rewrite this 5 times 9 to the 5x plus 1 times the natural log of 9. And really, you can write this in any order as long as you make sure that the multiplication is clear. So another option might be 5 times the natural log of 9 times 9 to the 5x plus 1. Any of these forms should be acceptable in MyMathLab and on a test. Example number 10, find the derivative of the following function. We have y equals negative 8 to the 7x squared minus 6. So to do our derivative here, we need to copy the original function. Opposite of 8 to the power 7x squared minus 6 times the derivative of the exponent. This is the chain rule part, 14x, and then the natural log of the base. Now we have to be careful here. Our base is not negative 8. If it was negative 8, that negative 8 would have to be in parentheses. So our base here is 8, okay? And you can't take the natural log of a negative or the log of any negative, so that should also be a reminder that that's natural log of 8, not natural log of negative 8. So we could do a bit of rearranging. We might put the 14x in the front times the opposite of 8 to the 7x squared minus 6 times the natural log of 8. And you could put that again in any order and it would be acceptable as long as you make it clear that it's multiplication. So 14x times negative 8 to the 7x squared minus 6 times the natural log of 8.